So still in chapter 3 with functions and their graphs. We're in section 3.4 now, which is your library of functions that you need to just know, and then piecewise defined functions, which can be kind of challenging. So give yourself time to work on this one. So the first objective is going to be to graph the functions listed in the library of functions. Some people call these parent graphs. And then the second objective is going to be to graph piecewise defined functions. Okay, so objective 1 is going to be to graph functions. So we're going to start with the square root of x, and we'll draw the graph on Desmos in class and talk about the domain and range and what the intercepts are and whether it's even or odd. So we'll look at the graph and answer these questions. So basically the square root graph, though, you should know, has a shape something like this, like the upper half of a sideways opening parabola. And then we'll have the cube root of x. Well, you can have negative numbers in the cube root function, so it looks like the cubic function turned sideways, and we'll talk later about why would that be, because there's a reason. And again, we'll talk about domain and range, x and y intercepts, odd or even, symmetry, that sort of thing. So cube root of x is a graph you should be able to just draw. Absolute value of x, the basic absolute value function, looks like this. And in fact, the best way to think about an absolute value function is as a piecewise function. So if you say this f of x looks like x if x is positive or 0. So it looks like the graph, this is y, it looks like the graph y equals x for positive values of x. And it looks like y equals negative x if x is a negative number. So over in this part of the graph, it looks like the graph y equals negative x. Okay, and then these are previously discussed functions that you should know how to graph. So f of x equals b. Remember, this is y equals some number. So this is going to be a horizontal line at y equals b. The identity function, remembering that f of x is y equals x, looks like the diagonal line. The squared function, you should know this one. This is your basic parabola. And then the cube function, 1 over x. This is a hyperbola where the y-axis, where x is 0, can't be on the graph of the function because then we would be trying to divide by 0. And we can see that as x gets very large, 1 over a large number is very small. So as x gets very large, y gets very small. And as x gets closer and closer to 0, y gets very large. And the point 1, 1 has to be a point on this graph. Well, if x is negative, we get the mirror image over here in quadrant 3, where the point negative 1 has to be a point on the graph. And it approaches but never actually touches the y-axis. And then we're going to skip the greatest integer function. It's kind of interesting and it does have uses, but it's kind of past what we need to know. So objective 2 is what I want to spend a little bit more time on because that's these piecewise defined functions. So they're in pieces and some functions are defined differently on different parts of their domain. In other words, you can't describe it by one equation for the whole thing. It needs to have different equations in different parts of the domain. So a useful way to think of the absolute value function is as a piecewise defined function. So I already talked about this earlier, but on the interval from negative infinity to 0, but not including 0, the function is defined as y equals negative x. So that's this line. Let me try that again. This line, y equals negative x. So that's the line y equals negative x. But we only want the part of it on this part of the x-axis, so we don't want this part over here. So you need to be clear about the meaning of this interval is x is less than 0. We're talking about this piece of the number line. Then on the interval from 0 to infinity, the function is defined as y equals x. So remember, y equals x is this diagonal line, but we're saying we only want the part of it where x is bigger than or equal to 0. So from here up is the part we want. And we don't want this part. So then you put those together on one graph and you're saying, oh, over on the left, I want the y equals negative x graph, and on the right, I want the y equals x graph. And that's your piecewise defined graph. So let's look at this one where we're saying y equals negative 3x if x is less than negative 1. So let's label our graph. And here is x is negative 1. So it could be helpful to think of the graph as being divided into vertical strips. So this is the strip where x values are less than negative 1. So in this area, we're saying y equals 3x. Well, that's a line. So let's come over here to x equals negative 10. Oh, then y would be negative 30, so that's going to be kind of hard to draw on this graph. But let's go instead to, let's say, x is negative 2. When x is negative 2, y is negative 6. So here is a point on this graph. When x is negative 3, y is negative 9. So here's another point on this graph. So we can see the shape of the graph is a line, and it goes all the way up almost until x is negative 1. So when x is negative 1, y would be 3. But that point is not a point on the graph. So we make an open circle. And I put my dots in the wrong places. Let me try again. When x is negative 2, negative 3 times negative 2 is positive 6. So let's try that. When x is negative 3 times negative 3 is positive 9. So there we go. So the line goes like this, comes right up until this open circle, but then there's an open circle here. So now we've graphed this part right here. Now it says y is 0 if x equals negative 1. So this says the point negative 1, 0 is a point on the graph. So that's where the dot goes. And do you see why you can't have two dots right above each other? Because then you would fail the vertical line test. Okay, so that's this part right here. And then the last part says y equals 2x squared plus 1 if x is bigger than negative 1. So here's the part of the graph where x is bigger than negative 1. So let's suppose x is 0. When x is 0, then y equals 1. So the point 0, 1 is a point on this graph. When x is 1, y is 2 times 1 squared plus 1, or 3. So the point 1, 3 is a point on this graph. And let's just do another one so we get a good shape. When x is 2, y equals 2 times 2 squared plus 1, or 9. So this is a parabola. And if x could be negative 1, y would be 2 times negative 1 squared plus 1, which would be 3. So that would be this dot right here. So it actually would be filled in that case, but it's not. So I need to take away that part and make it back to open circle. Here's this line. Then the open circle goes to the parabola on this side. So this graph is a straight line for this part, the dot for this part, and then the parabola for this part here. So f of negative 2 says come over to x is negative 2 and go up to the graph and see where the point is, and f of negative 2 equals 6. Because when x is negative 2, we're in this first area where this is how the function is defined. F of negative 1 equals 0 because that's how it's defined right here. Here's the dot that says f of negative 1 is 0. When x is negative 1, then y is 0. And then f of 0 is 1. And that's because when x is 0, it's defined by this third description of the graph. So that's where you plug the 0 in. Okay, so that's a piecewise defined function. So let's do this one in class together. And let's look at an example where you have a graph given and you find the piecewise description of it. So let's look first at what the domain of this graph is. So we start at negative 1, and negative 1 is included. When I get to 0, it's still defined at 0, and as I get bigger and bigger, and in fact, it keeps on going forever. So that's the domain. So we definitely need to define this function in that whole domain. So the function is going to look like two pieces because we can see there's this line and this line. So when x goes from negative 1 up to 0 and including 0, then we need to describe that line right here. So from x is negative 1 to x is 0, we need an equation of this line. Well, we can see the slope of this line is up 2 over 1. So the slope is positive 2. And then we can see that the y-intercept is 0, 2. So the equation of this line is y equals 2x plus 2. So the function is defined as 2x plus 2 in the part of the graph where x is between negative 1 and 0. Okay, then the other part we need is if x is bigger than 0, strictly bigger than 0. You can't have 0 included on both parts. That would be an error. So let's look at this line now and see what the slope of this one is, up 1 over 1. So m is 1. And the y-intercept is 0, so this is the line y equals x. So we say this function is defined as x for all the values of x that are greater than 0. And then let's do number 45 together in class. And that's it for this section.